These are the 1.3a notes for PreCalc. We'll be talking about transformations of graphs today. So we talked about the parent functions. Those are always centered at the origin, and then they can move around. They can change directions, shapes, sizes, etc. So we'll talk about the four things that can happen. First of all, there's a vertical shift. That's when you would move the graph up or down. And you can tell that that's happening because there will be a number at the end. So number at the end of the problem. For example, this plus 5 means the graph would shift up 5. Also, the square tells us it's a parabola quadratic. The absolute value of x minus 3, the minus 3 would move that down 3 places. And of course, we know the absolute value makes a V shape. Then at the end here, you have more of a generic or general function, just f of x. We don't know exactly what that looks like, but we do know it moves up 10. Then you have horizontal shifts. Horizontal shifts are when the number is on the inside, some sort of grouping symbol. So that grouping symbol could be parentheses, it could be absolute value, it could be square root. And for these, it's always going to be the opposite sign. So this plus 2, notice it's inside the parentheses. It's actually going to move it negative 2 or left 2 places. The square on the outside tells us it's a parabola. The next one, y equals the square root of x minus 3. That minus 3 is considered to be inside the square root bar. That'll be a right-left movement. And again, that would be the opposite direction, so that would be to the right 3 places. Our general function at the end, f of x minus 9, that minus 9 is inside, and that would move to the right 9. Then we have our flips and reflections. So if the negative, this always has to do with negatives, if the negative is on the outside or in front, it's going to flip it up down. If the negative is on the inside, again, that could be parentheses, that could be a cube root, whatever, inside something, that's going to move it to the right or left, flip it from right to left. So on this first one, y equals negative 1 over x, that is going to be a flip up down. That is negative considered to be on the outside, as opposed to the next one you can see where the negative is on the inside of the parentheses. That one's going to flip it right to left. The last one, our general function f of x, the number is on the outside. The negative is on the outside, so it's going to flip up down. Just a quick comparison, if they wanted this last one to flip right left, it would look like that. The negative x would be on the inside of those parentheses. It's not what we have, so this one flips up down. The last type of change or transformation these graphs could happen is a stretch or a compress, and that's when you have a number in front. It's going to make the graph stretch, meaning grow taller and skinnier, or compress, grow wider and shorter. So when I look at this first one, y equals 3 square root of x, what's going to happen to this graph is this is going to get 3 times as tall. So just as an example, so you can see it, you don't have to write this down, but I just want to show you a normal square root graph would look something like that. And if you put a 3 in front, it's going to get just that much taller. It's going to look more like that. So it's going to grow taller. Right? The next one, half in front, is going to mean it's half as tall. And the 5 in front would mean 5 times as tall. Okay, so for the 8 problems below, I would highly suggest pausing the video right now, looking through these, Many of them have more than one transformation in it. So I would pause the video and go through some of these as best you can, and then turn on the video and I'll run through the answers. So go ahead and pause the video now, and then we'll check back in a moment. Hopefully you had the opportunity to try these. I'm going to run through these pretty quickly. If you have any questions, you can, of course, ask me in class or send me an email. This first one, the -1 is on the inside, so that's going to move to the right one place. Number 2, the negative is on the inside, so that's going to flip to the right left. Number 3, there is a 2 in front, so that means that the graph is going to be stretched 2 times as tall. Problem 4 actually has 3 changes to it: the negative, the 5, and the 8. So the negative in front is going to flip it up down. The 5 is going to make it 5 times as tall. And then the 8 at the end of the problem is going to move it up 8. Number 5. All we have here is a +4 at the end, which means the graph will move up 4. Problem 6. Again, 3 things happening. It's going to be half as tall. The 3 on the inside is going to move at the opposite direction, so left 3. And the -7 at the end is going to move the graph down 7. Problem 7 also has 3 things happening. A negative in front will be a flip up down. The 8 on the inside will move it left 8. And the +1 at the end will move it up 1. Problem 8, negative on the inside is going to flip or reflect. Sometimes they use the word reflect, right to left. And the +2 at the end is going to move the graph up 2. All right, let's take a look at our problems on the back. So this is actually going to have us graphing some things. When you do this on Delta Math, it's going to be a lot simpler because you can drag the entire graph on Delta Math just by pulling the main point, the vertex point. But I wanted to make sure that you had some examples on your notes. So problem number 9, the graph of y = x squared is shown. We're going to graph y = x squared -4. So we first have to decide what the -4 does. That's going to move it down 4. So we'll take the major point of the parabola, this 0, 0, and we're just going to move that down 4. And you could take the next point here and move it down 4. Or you could think about the 1, 3, 5 rule, which means we'll go up 1 over 1, up 3 over 1, and then up 5 over 1. That might be a slightly faster way to graph it. Just following that 1, 3, 5 rule. Problem number 10, our general function f of x. We have that x +7 on the inside, which means it's going to move to the left 7 places. So for this graph, I would identify a few of the most important points. Maybe where the graph starts down here, and then anytime it changes directions. And just shift each of those points over 7 places. And then from there, you can just connect the dots, make that same shape. Problem 11 is a square root graph. It has 2 changes happening, 2 transformations. It has a negative in front. That's going to flip it up, down. It also has a -5. That -5 is not inside the square root bar. You can see the square root bar ends before the -5 starts. That means it's at the end and it's going to move down 5. All right, so I'm going to do the down 5 first. I'm going to take the vertex of my square root graph and move it down 5. Maybe to there. And then this also has a pattern of 1, 3, 5. So it's up 1 over 1, up 1 over 3, and up 1 over 5. I'm going to use that same pattern, except instead of going up and over, I'm going to go down and over. So I'm going to go down 1 over 1, down 1 over 3, and down 1 over 5. So I can create that same shape, but it's flipped upside down. And I will take care of my flipping up down. For the next 3 problems, we are going to be writing the equation, the function that represents the dotted graph. So the solid black is the original, and then your dotted is the transformation. So let's see what we notice about this problem. We know it's an absolute value. They gave us that already. It also looks like the graph got flipped upside down. So flip up, down. And it looks like it got moved to the right 4 places. So we'll write our equation with a base of y equals absolute value of x. And we'll just add the things in that we need. When you need to flip something up and down, there would be a negative in front. And when you need to move something right, you would actually make it inside as x minus 4. And that would be our answer for that one. Number 13 is just giving it to us as a general graph, so f of x. Let's notice what's happening. The black graph is your original, and we can see that it got moved over 3 and up 3. So it got moved left 3 and up 3. We don't have to take into account that it's upside down because the original is upside down. So our graph did not get flipped. Right, this is going to look like this. The left 3 is going to go on the inside as the opposite sign. So that's that 3 right there. And then the plus 3 is going to come at the end as a plus 3. All right, the last one, f of x. Again, another general graph. Looks like we have half of a circle. And you can just look at any point along this circle, this half circle, semicircle. I'm just going to look at that point and compare it to that point right there. But you could obviously choose a different point as well. Okay, it looks like this graph got shifted left 5. Left 5 and down 2. So left 5 and down 2. Left 5, always the opposite direction, opposite sign of what it looks. So we'll put that in as a plus 5. And then down 2 would be a minus 2 at the end.